September 15, 1940, 11:47 a.m. 23,000 feet above Kent, England. Squadron leader Douglas Bader sharply banks his Hawker Hurricane to the left as tracer rounds whiz by, just missing his cockpit. Behind him, a German Bf-109 has already claimed the lives of two of his pilots earlier that morning. Bader can't spot it. No one can until it's too late. The situation is grim. Within the first 4 months of the Battle of Britain, RAF Fighter Command loses 1,547 aircraft. Of those, German fighters are responsible for 792 kills. In 73% of these cases, British pilots don't see the enemy until it's too late. They're dying without warning. The Hurricane is more maneuverable than the Bf-109, and British pilots are aware of this, but you can't dodge what you can't see. The rear visibility in the Hurricane is horrendous. The armored headrest, meant to protect pilots from head-on attacks, creates a massive blind spot extending 45 to either side. Pilots have to strain their necks to spot an enemy trying to climb behind them. By October 1940, the average life expectancy of a Hurricane pilot is only 87 hours of flying, just 4 weeks. What no one knows, not Bader, not Air Chief Marshal Hugh Dowling, or even the Luftwaffe pilots hunting them, is that a 34-year-old engineer with no aeronautical degree, working in a small workshop with fabric scraps, has already found a solution. His idea costs 11 shillings per aircraft. The Air Ministry will dismiss it as absurd. Senior engineers will say it's aerodynamically impossible, and test pilots will refuse to fly with it. Yet, this solution will save more lives than any other modification in RAF history. Royal Aircraft Establishment, Farnborough, Hampshire, August 1940. The conference room is filled with Britain's leading aeronautical experts. Air Vice Marshal Trafford Lee Mallory stands at the front, pointing to a blackboard covered in diagrams and casualty statistics. The numbers paint a picture of relentless destruction. "Gentlemen, we're losing the visibility war," Lee Mallory begins, tapping a diagram of the Hurricane's cockpit. "Our pilots have a 90 blind spot directly behind them. The 109 pilot positions himself in that blind spot, closest to 200 yards, and opens fire. The pilot never sees him until the first rounds hit, tearing through the fuel tanks." Proposed solutions are outlined across 3 pages of memoranda. Hawker Aircraft suggests a complete redesign of the canopy, which would take at least 18 months, assuming no production delays. Another team proposes installing mirrors, but wind tunnel tests reveal they create turbulence that reduces the top speed by 4 miles per hour. At combat altitude, that's the difference between catching a bomber and letting it escape. Dr. Frederick Lindemann, Churchill's scientific advisor, proposes rearward-facing cameras with cockpit displays. But the technology doesn't exist and the cost is astronomical. Squadron leader Peter Townsend, who has just recovered from wounds suffered in a dogfight he never saw coming, offers a pilot's perspective. "We're breaking our necks trying to look behind. I've seen men pull muscles so badly they can't turn their heads for a week, and the 109 still get through. We need to see behind us without turning." Henry Tizard, chairman of the Aeronautical Research Committee, responds, "There's no simple solution. The Hurricane's design is fixed. We can't move the headrest or its armor plate, which is essential for pilot protection. We can't raise the pilot seat. The cockpit geometry won't allow it. We certainly can't extend the canopy. Reworking the production line would take months, and we're already struggling to replace combat losses." The expert consensus is clear. Improving rear visibility would require a complete airframe redesign. The Hurricane will have to fight with its blind spot, and pilots will continue to die at current rates until the Spitfire, with its superior visibility, replaces it as the primary fighter. The estimated timeline for this is mid-1941, but the stakes are dire. RAF Fighter Command is losing experienced pilots faster than training schools can replenish them. Meanwhile, the Luftwaffe grows bolder, and Hitler's invasion barges are massing in French ports. Britain needs a solution now, not in 9 months. But engineering reality seems to offer no solution. The meeting ends with no actionable recommendations. In Brooklyn's aircraft factory the same day. Frederick George Miles doesn't seem like the person who will change the course of fighter combat. At 34, he's a self-taught engineer who left school at 16 to work in his father's furniture workshop. He has no university degree, no formal aeronautics training, and no experience designing modifications for fighter planes. What he does have is a small aircraft company, Miles Aircraft, which builds training planes under contract, and a keen interest in what pilots have to say. Miles spends his lunch breaks in the factory canteen listening. Today, a Hurricane pilot named James Nicholson describes his recent combat experience with striking detail. Nicholson will later be awarded the Victoria Cross for continuing to attack a German bomber while his plane burned around him. But right now, he's focused on a different issue. "I knew he was back there," Nicholson says, stirring his tea. "I could feel it, like when you sense someone watching you, but I couldn't confirm it without breaking formation and turning. By the time I turned, he'd already opened fire. Put 20mm rounds through my reserve tank." Miles leans forward. "What if you could see him without turning?" He asks. "They tried mirrors, but mirrors don't work." "Not mirrors," Miles says slowly, an idea taking shape. "What if the air itself could give you a clue?" That evening, Miles stays late in his workshop, surrounded by fabric samples and technical drawings. He's thinking about something he noticed during a windstorm last winter. He observed how fabric stretched over a frame vibrated and rippled in turbulent air, revealing wind currents. Aircraft move through air similarly. They leave disturbed air trailing behind them, like a ship's wake. A pursuing fighter has to fly through this disturbed air to close in for a kill. What if there was a way to make this disturbance visible? Miles takes a roll of lightweight cotton fabric, the same material used for control surfaces, and cuts a strip 18 inches long and 3 inches wide. At his workbench, he makes a simple frame from piano wire, the same high-tensile steel used in aircraft control cables. The fabric strip attaches to the frame with quick-release fasteners. The concept is simple. Mount the fabric strips on the Hurricane's upper wing surface, just behind the cockpit, where the pilot can see them in his peripheral vision. When a pursuing aircraft enters the Hurricane's wake, the disturbed air will cause the fabric strips to flutter and ripple in distinct patterns. The pilot won't need to turn around. He'll see the warning in his peripheral vision and instantly know that an enemy is closing in from behind. Miles sketches the mounting configuration. The strips will be attached to the wing's leading edge, angled slightly upward to catch the maximum airflow. The total weight, 4 ounces. The cost, 11 shillings for materials and labor. He stares at his crude prototype. It looks like something a child might make for a school project. The Air Ministry will dismiss it, but he decides to test it anyway. Brooklyn's aircraft factory. September 3, 1940, 6:15 a.m. Miles arrives before dawn, carrying his fabric strips in a canvas bag. On the tarmac sits a Hurricane MKI, grounded for routine maintenance and officially unavailable for flight testing. Miles convinces the maintenance crew chief, Albert Simmons, to look the other way for 20 minutes. "This is completely irregular, Mr. Miles," Simmons mutters, positioning a ladder against the Hurricane's wing. "If Group Captain finds out I let you modify a service aircraft without authorization, we'll just not tell him," Miles replies, climbing onto the wing. The fabric strips attach with spring clips designed to grip the wing's leading edge. Installation takes just 12 minutes. The fabric strips flutter gently in the morning breeze, looking out of place against the hurricane's war-weary camouflage. Test pilot George Bullman arrives, coffee in hand, and freezes when he sees Miles's work. "What in God's name is that?" he asks. "Visibility enhancement system," Miles replies, climbing down. "It looks like you've decorated a fighter with ladies' handkerchiefs." Bullman circles the aircraft slowly, inspecting the strips. "The Air Ministry hasn't approved this," he says. "This modification hasn't been wind tunnel tested. We have no data on how it affects handling characteristics. For all we know, those strips could tear off at high speed and damage the tail surfacers, or they could save lives." Miles counters, "That's not how we do things. There are procedures, protocols, safety reviews, but while we follow those, pilots are dying. 87 hours, George. That's the average combat life expectancy right now. 87 hours. Bullman stares at the fabric strips, then at Miles. "If something goes wrong up there, it's my license." "I know," Miles says. "And if this works, you're taking full credit. I'm not having my name attached to something that looks this bloody ridiculous." "Deal." Bullman climbs into the cockpit, and the Rolls-Royce Merlin engine coughs to life. Miles watches as the Hurricane taxis to the runway, turns into the wind, and takes off. The fabric strips flutter violently in the slipstream but hold firm. For 20 minutes, Bullman puts the Hurricane through steep climbs, sharp turns, and high-speed dives. When he lands, his face is unreadable. "Well?" Miles asks. "They work," Bullman says quietly. "I had Simmons chase me in the Milesmaster trainer. Every time he closed to within 400 yards, the strips went wild. Different patterns depending on his position directly astern ripple from the quarter. I could tell where he was without looking." "So we show this to the Air Ministry?" Miles asks. Bullman laughs bitterly. "You show this to the Air Ministry, they'll have you committed. This violates every principle of clean aerodynamic design. It's fabric tape stuck to a fighter with spring clips. Senior engineers will call it amateurish, dangerous, and absurd. They'll never approve it. Then what do we do?" Miles asks. "We bypass them," Bullman says. "We go straight to someone who cares more about dead pilots than proper procedure. Fighter Command Headquarters. Bentley Priory, September 10, 1940. 2:30 p.m. The conference room is filled with hostile faces. Air Vice Marshal Lee Mallory has gathered the same experts who declared the visibility problem unsolvable 3 weeks ago. Now, they're being told that a furniture maker's son with fabric strips has found a solution they missed. Miles stands at the front of the room, his crude prototype mounted on a demonstration board. Dr. Reginald Mitchell's successor at Supermarine. Joseph Smith examines the strips with barely concealed contempt. "This is your solution?" Smith asks. "Fabric tape. Fabric strips mounted on spring clips?" Miles responds, "They detect disturbances in the airflow caused by pursuing aircraft and provide a visual warning to the pilot." "Aerodynamically impossible," declares Dr. William. "Foreign from the Royal Aircraft Establishment. The Hurricane's own slipstream would cause ... constant flutter," Dr. Foran says dismissively. "The pilot would be bombarded with false warnings nonstop. It would be worse than useless. It would be distracting." Miles remains calm. "Test data says otherwise," he responds, handing over Bullman's flight report. In 17 simulated attack approaches, the strips provided accurate warnings every single time. No false positives. The room erupts in voices, questions flying. Unauthorized testing on a service aircraft. Someone shouts, "Where's the wind tunnel data? What about structural integrity at high speeds?" This violates Air Ministry Specification F3634. Sir Henry Tizard raises his hand for silence. Mr. Miles, I appreciate your enthusiasm, but we cannot modify frontline fighters based on one unauthorized test flight. Those strips could tear off and cause catastrophic damage. They could affect handling. We can't make decisions based on theoretical data, especially when proper testing protocols haven't been followed. Miles interrupts, his voice firm. How many pilots died while you were discussing testing protocols? The room goes quiet. Yesterday, we lost 14 Hurricanes. Last week, 41. The Luftwaffe is killing our pilots because they can't see their attackers. I'm offering a solution that costs 11 shillings per aircraft and takes 20 minutes to install. How many more men have to die before we try something different? That's quite enough, Tizard says coldly. Everyone turns to see Air Chief Marshal Hugh Dowding, who has entered the room quietly. At 58, Dowding commands RF Fighter Command and feels the weight of every pilot's death. His face is stone, his eyes haunted by casualty lists. Sir, Miles says. Show me how they work, Dowding replies, cutting him off. Not in a conference room, in the air. Tizard protests. This device hasn't been properly evaluated. Neither had radar when I approved its installation, Dowding snaps. Neither had the Spitfire's 8-gun armament. And there were a dozen other innovations that everyone said were impossible until we made them work. Mr. Miles, you'll demonstrate your strips tomorrow at Northolt. I'll observe personally. If they work as you claim, I'll authorize immediate field testing with operational squadrons. If they don't, you'll remove them and never waste my time again. Understood? Yes, sir, Miles replies. Good. We're losing this battle. Not because our pilots lack courage or skill, but because they're fighting blind. If fabric strips can change that, I don't care if they look ridiculous or violate aerodynamic principles. I care whether they save lives. The meeting adjourns. Northolt, September 11th, 1940. 10 a.m. 3 Hurricanes are lined up on the runway. One has Miles's fabric strips installed, and the other two are unmodified. Dowding stands with his arms crossed, watching as Squadron Leader Douglas Bader, the legless pilot who's become a legend, inspects the strips skeptically. You want me to fly with handkerchiefs on my wings? He asks. I want you to survive, Miles replies. The test protocol is simple. 2 Hurricanes will try to position themselves in Bader's blind spot and close to firing range without being noticed. The Bader will fly the modified Hurricane first, then an unmodified one for comparison. There's radio silence throughout. The pilots must rely entirely on visual detection. Bader takes off, climbs to 15,000 feet, and starts flying a combat air patrol pattern below. Dowding watches through binoculars as the 2 pursuers close in. In the modified Hurricane, Bader sees the fabric strips in his peripheral vision. They're calm at first, fluttering gently in smooth air. Then, suddenly, the left strip starts rippling. It's a distinctive wave pattern moving from front to back. Bader glances to the left and back, nothing visible, but the strip doesn't lie. He brakes hard left, pulling 4 Gs, and a Hurricane flashes through the space he just vacated. Contact, Bader radios. Left quarter 400 yards. The pattern repeats. The right strip ripples. Bader brakes right, catching his pursuer climbing for altitude. Contact right quarter. Both strips flutter simultaneously. Directly astern, Bader calls, executing a barrel roll that puts him nose to nose with his pursuer, on the ground. Dowding's expression doesn't change, but his chief of staff notices his grip tighten on the binoculars. The second test in the unmodified Hurricane tells a different story. Bader twists in his seat, craning his neck, desperately trying to spot his pursuers. He catches one by chance and sees the other only when it breaks off. 2 contacts, Bader radios. but I had to work bloody hard for them. After landing, batter walks straight to Miles. How soon can you put these on every hurricane and fighter command? The formal testing begins immediately. Over the next 10 days, 12 operational pilots fly 57 simulated combat missions. The results are clear. Without strips, pilots detect pursuing aircraft 31% of the time before simulated firing range. The average detection distance is 380 yards. With strips, pilots detect pursuing aircraft 89% of the time. The average detection distance is 520 yards. That extra 140 yards, the difference between evasive action and taking cannon fire, is critical. On September 25, 1940, Dowding authorizes immediate production and installation. Miles Aircraft receives a contract to manufacture 10,000 sets. Installation begins with frontline squadrons. The next day, October 4, 1940, at 2:15 p.m., 20,000 feet above the English Channel above London, pilot officer Eric Lockett is flying his first combat mission since his Hurricane was fitted with Miles's strips. At 20 years old, with just 17 hours of combat experience, Lockett represents the type of pilot the RAF is losing far too quickly. His squadron No. 41 RAF is assigned to intercept a formation of Hinkle bombers. Escorted by Bf-109s, the bombers are easy to spot in tight formation. Lockett positions himself for a beam attack on the lead bomber, but doesn't notice the Bf-109 that drops from 6 o'clock high, lining up for a kill shot. The fabric strips, however, see it. Lockett catches the motion in his peripheral vision, both strips rippling violently. Without thinking, he brakes hard right, pulling so sharply that gray edges blur his vision. Cannon shells tear through the space his cockpit occupied just a second earlier. Lockett reverses, climbing hard, and finds himself nose to nose with the Bf-109. Both pilots fire. The Germans' rounds miss, but Lockett's don't. The 109's canopy shatters, and the aircraft rolls inverted, trailing smoke. Locke doesn't have time to celebrate. The strips are rippling again. Another 109 is closing from the left quarter. He breaks left, spots the enemy fighter, and maneuvers for position. The dogfight lasts 90 seconds. When it ends, Locke has his second kill of the day, and his Hurricane has 3 bullet holes in the tail, but none in the cockpit or fuel tanks. "I saw him coming," Locke reports during debriefing. "Not with my eyes, with those bloody strips. They gave me 2 seconds of warning. That's all I needed." Combat reports flood in over the following weeks. Squadron after squadron reports the same pattern. Pilots are surviving encounters they would have died in before. The statistics tell the story. In September 1940, before the strips, the Hurricane loss rate to fighter attack was 73 aircraft per 1,000 sorties. By November 1940, after the strips, the loss rate dropped to 44 aircraft per 1,000 sorties. That's a 40% reduction in losses. In human terms, that's 40% fewer telegrams sent to mothers, wives, and children. 40% more pilots surviving to fight another day. The Germans take notice. Luftwaffe intelligence reports mention mysterious fabric devices on RAF fighters. Oberfeldwebel Franz von Foy, shot down and captured in September, mentions them during interrogation. "The Hurricanes started evading our attacks before we even opened fire. We thought they had rear-facing radar, some new British technology. Then I saw one on the ground after I was captured. Fabric strips, like children's toys, but they worked." Our kill ratios dropped significantly in October. The Hurricane pilots were no longer blind. By December 1940, Miles's strips, now officially called Airflow Warning Devices, Type M, are standard equipment on 47 Hurricane aircraft. The modification spreads to other aircraft types. Spitfires receive them in January 1941, and modified versions will be used on American P-51 Mustangs starting in 1943. The story becomes even more remarkable from here. If you haven't already, hit that like button and subscribe. We're just getting started with these hidden histories that forever changed. Warfare. The lives saved are impossible to calculate precisely, but RAF operational research estimates that at least 340 pilots survived encounters they statistically should not have, thanks to early warnings from the strips. That's 340 men who came home, 340 men who trained the next generation of pilots, 340 men who flew in the campaigns that followed North Africa, Italy, France. Pilot officer Eric Locke survives the Battle of Britain and becomes one of the RAV's top aces, with 26 confirmed kills. He credits the strips with saving his life at least 4 times. Locke dies in August 1941, shot down over France, but he lives long enough to train 12 new pilots, 3 of whom survived the war and credit Locke's lessons with their survival. The ripple effects continue across generations. Miles Aircraft Factory, Surrey. May 8, 1945. Victory in Europe Day. Frederick Miles stands in his workshop, surrounded by celebrating workers. Someone thrusts a glass of champagne into his hand. The war in Europe is over. Britain has survived. A delegation arrives, including 3 RAF officers in peacetime uniforms and a young man in civilian clothes. The young man steps forward and extends his hand. Mr. Miles, I'm James Nicholson. We met once in 1940. You were asking about visibility. Miles remembers the hurricane pilot in the canteen, the conversation that sparked everything. I wanted to thank you, Nicholson continues. I flew with your strips for 4 years. They saved my life twice that I know of. Probably more times I'll never know. Because of you, I came home. Because of you, I got married last year. Because of you, I'll have children who will never know how close they came to not existing. Miles doesn't know what to say. He's never been comfortable with gratitude. The senior officer, now a group captain, produces a document. The Air Ministry wishes to recognize your contribution to the war effort. We're recommending you for the Order of the British Empire. Additionally, there's the matter of compensation. Your innovation saved the Crown millions of pounds in aircraft replacement costs, not to mention the incalculable value of lives preserved. We're prepared to offer ... No, Miles interrupts quietly. I'm sorry. I don't want recognition. I don't want compensation. I did what needed doing. That's all. Mr. Miles, you saved hundreds of lives. I made fabric strips. Pilots saved lives. They're the ones who flew into combat every day. They're the ones who deserve recognition. The officers exchange glances. At least accept the OBE. I appreciate the offer, truly, but no. Give those honors to the pilots. Give them to the ground crews who kept the aircraft flying. I'm just an engineer who got lucky. Miles never accepts official recognition. He refuses interviews, declines to write his memoirs, and asks that his name be removed from official histories. When aviation historians track him down in the 1960s, he tells them the same thing. The strips worked because pilots trusted their instincts. I just gave them a tool. The courage was theirs, not mine. The fabric strips remain in service through 1,945. Total production, 23,470 sets. Installation occurs on 14 different aircraft types across 5 air forces: RAF, RCAF, RNZAF, USAF. Post-war analysis by the RAV's Operational Research Section estimates that 820 pilots survived encounters they statistically should not have, with the strips as a contributing factor. The technology seems primitive now, almost laughable. Modern fighters have radar warning receivers, missile approach warning systems, and 360 sensor fusion. But the principle Miles discovered, using airflow disturbance to detect threats, remains valid. Modern UAVs use pressure-sensitive arrays to detect nearby aircraft through wake turbulence. The physics hasn't changed, only the implementation. Miles dies in 1976, age 70, after spending his post-war years designing light aircraft and mentoring young engineers. His obituary in the Times mentions his wartime work in a single sentence. No one from the Air Ministry attends his funeral, but in 2003, a group of Battle of Britain veterans, now in their 80s, commissioned a memorial plaque at Brooklands. It reads simply, Frederick George Miles, 1906 to 1976 engineer. His fabric strips gave us seconds. Those seconds gave us our lives. The lesson isn't about technology. It's about humility, persistence, and the courage to trust simple solutions when experts insist only complexity will work. Miles didn't have the credentials, the authority, or the resources of the establishment. He had a workshop, some fabric, and the willingness to try something ridiculous. Sometimes, ridiculous is exactly what's needed. Sometimes, the difference between life and death is 11 shillings worth of fabric and the courage to ignore everyone who says it won't work. Sometimes, the greatest innovations come not from laboratories and research committees, but from someone who simply refuses to accept that young men should die blind. End.